Hello. In this video, we're going to talk about how to do a unit conversion. Unit conversions are also known as dimensional analysis. When we do a conversion, we're going to be using what I call the power of one. By power, I mean the special abilities. I don't mean it like an exponential way. Okay, we're going to see that this number, the number one, has a very special ability. It'll allow us to convert anything to any unit we want. Okay, so the first thing I want us to keep in mind regarding the number one is that anything times one is equal to that very same thing. Okay, just so that we're on the same page, if I were to write something like 2 times 1, it'd be equal to 2. If I wrote something like A times 1, that would be equal to A. If I did something silly like Josh times 1, that would be equal to Josh. All right, so that is to say, multiplying any value by 1 is equal to that same value. All right, so this is something I want us to keep in our mind as we try to do a conversion. All right, I only have one real main example problem today, and that's going to be right here. Let's say we were measuring the mass of something, and we got 8.93 grams as the mass of something like a pen or something is maybe around 9 grams or so, 8.93. So let's just say we measured the mass of a pen. We want to calculate in this problem, in this question, how many milligrams is equal to 8.93 grams. All right. Or sometimes me or other people may write the problem this way. Instead of with an equal sign, we might write an arrow. We're asking the same thing here. All right, so from 8.93 grams to something in milligrams. All right, grams is what I'm going to call the unit we need to go bye-bye. This is the unit we don't want. This is the unit we want to get rid of. This is the unit we want to cancel. Milligrams is what I'm going to call the unit we want. All right, so we're going to go from here to here using the power of 1. All right, so my steps and thoughts, I write out in this violet purple sort of shade. And the actual work I'm doing, I'm writing in black. Okay, and you'll occasionally see me color code or shape code some things. All right. So first step, with any problem, the first step, the first thing to do is to write out the piece of information they gave you. All right. This is especially a good idea in which you're in a situation where you're just looking at the problem and you're like, where do I start? Okay. Start by just writing out the value that they gave you. Okay. I know for me, when I do that, that will calm my anxiousness about what to do. All right. So we wrote out 8.93 grams. Okay. G standing for grams. In case you haven't gone through any sort of videos or lessons about what this lowercase g stands for. It stands for grams, a unit of mass. All right. So the next step is we're going to multiply 8.93 grams times 1. By doing this, we haven't changed what 8.93 grams is. We haven't changed it because anything times 1 is that same thing. Okay. All right. We have a few more steps here. So we will return to this statement in a minute. Okay. Now let's remind ourselves we need to go from grams to milligrams. All right. And so what we want to do, okay, we'll put this in the back of our mind in the back burner. Okay, we want to find a relationship that relates grams to milligrams. Okay, this is what we need to do. All right. I came up with 4 examples. Any of these will work. And we could even maybe come up with fractional examples or something. I just want to keep it more on the simple side, okay? I'll just read off each of these 4 options, all right? 1 gram is equal to 1,000 milligrams. Okay, this we know to be true. because milli means 1,000th. Okay, the milligram is the small thing. We need 1,000 milligrams in order to get to 1 gram. Okay, if you're doing powers of 10, you could have a 10 to the third power here instead of a 1,000. Okay, and then these statements are also mathematically equal to any of these statements. Okay, a gram, the big thing, is going to be it's going to be bigger than a milligram, but if we shrink it, if we multiply it by 1,000th, then we get it to be equal to the smaller milligram. And same idea here using scientific notation. I like to work with positive powers of 10. I like to work with powers of 10 that are easier to write. I find a decimal to not be as favorable for me. You do things your style, but going forward in this video and probably other videos, I'm going to be using one of these sort of conversion factors. All right. All right. So, but back to the matter at hand. All right. We do 8.93 grams times 1. Okay. And we're going to try to take advantage of this 1. We're going to try to relate this statement. I'll choose this one today. I'm going to try to relate this to the number 1. All right, next slide. Okay. All right. So we're going to make some fractions. All right. On the previous page, I had a post-it note here. These statements are called equivalent statements when you show how one number with 1 unit is equal to some different number with some different unit. All right, these are called equivalence statements. Okay, so with the equivalence statement that I chose earlier, this one, 1 gram equal to 1,000 milligrams, I made 2 such equivalent statements. All right, I have 1,000 milligrams divided by 1 gram. Or we could do the other way. Okay, we could just flip them and we would get 1 gram over 1,000 milligrams. All right. And when we make something like this, these are called conversion factors. Right. These are both conversion factors. All right. So let's continue with my narrative here. All right, so both of these fractions are forms of the number 1. That's one of my main arguments today. When we're coming up with this idea of a conversion factor, we're actually just making a fancy version of the number 1. Okay, because we said earlier that 1 gram is the same as 1,000 milligrams. Okay, if we divide 1 gram by 1,000 milligrams, in one sense, we're dividing 1 gram by another form of writing 1 gram, which is 1,000 milligrams. We divided one thing by another thing it's equal to. So that should be 1. Okay. All right. So we've made 2 different forms of the number 1. Okay. Now this is where we are heading into the territory of being closer to being able to do a unit conversion. All right. We're going to choose the fraction that gives us the unit we want and cancels the unit we don't want. Okay, again, I'll say that again. We want to choose the fraction that will give us the unit we want and takes away the unit we need to go by, the unit we don't want. All right. And once we choose that fraction, we're going to substitute that fraction. I'm calling it the good fraction. We're going to substitute it for this number 1 we have right here. Okay. We're going to find which one we want to substitute into this number 1. Okay. So next page, there's going to be an answer. Okay. And I'm going to go with this fraction. Okay. 1,000 milligrams over 1 gram. I am not going with the other fraction. Okay. I'm going to go with this fraction. And that's because, well, first let's keep track of score. Okay. Oops. Oh, I was going to do that. Whatever. Okay. Sorry for this little tangent. I just want to really make sure that fraction, you take it out of your notes. Okay, take it out of your notes, cross it out, cover it, whatever. Okay, that's the units we want. Those are the units we need to go by. All right. And let me show you why. Okay. By choosing that fraction, we have grams over grams. Okay. Anything divided by itself is going to be equal to 1. And once you have a 1, then we know that anything multiplied by 1 is going to be that same thing. Right? And that's going to leave us with milligrams. Okay. I'll show that completely in a minute. I just want to show the opposite. What if we had chosen the other one? Okay, we had chosen the other one. As we do the math, we would have a strange set of units. We would have units of grams squared over milligrams, which I cannot make any sense out of. That doesn't make sense. All right. So that's why we want this conversion factor. Okay. So I wrote out my argument completely here. Okay. By choosing this conversion factor, we are going to be left with just the units of milligrams. Okay. Grams over grams equal to 1. Anything times 1 is that same thing. All right. So here's my work. Okay. Just rewriting it. Here's the next phase of my work. I just made that fraction bar a little bit longer. You can see me canceling out my grams. They go bye-bye. Hello to the milligrams. And once all the dust has settled, then I'm left with 8.93 times 1,000 milligrams, the only units to survive this mess. Sometimes I'll call the canceling of units the unit apocalypse, all right? By the way, random comment, but I just love the feeling of canceling units. I find that to be a very satisfying thing. For me, it's almost as good as like eating a really good slice of New York style pizza. All right. That's just me though. All right. We canceled the amount. I guess that 1, we could have brought it over. So I did there. And anything divided by 1 is that thing. So now that all the dust has settled, we can just type this into the calculator. Okay. All right. So 8.93 times 1,000. Sure, you can divide by 1 if you really feel like it, equals, and then 8,930 milligrams is our answer. All right, great. So we just did dimensional analysis. We just did a unit conversion. All right. All right, so that was the main thing for this video. I will give some parting thoughts, though. Fractions versus brackets. Okay, I'm going to cover that a little bit. The long story short, they're both good. They both work. All right. And then the other thing, I get a lot of questions about this. How do I like actually type this into the calculator? Especially on maybe a little bit longer of an example. Right. So I have a longer example here. And my hope for this channel is to continue to have more examples and even longer ones in this upcoming one. But before I get to that, I want to talk about the fractions versus bracket thing, because this is going to influence how we actually write out our problems. All right. So everything I was doing so far with our unit conversions, dimensional analysis, by the way, I don't remember I said this. I'll just leave this part. It's just a fancy way of saying unit conversions. All right. Dimensional analysis, unit conversions, it means the same thing. All right. So dimensional analysis with fractions, this is what we were doing earlier. Another way you can write out something like this is with brackets, okay? Or some people call this like the fence. For me, this reminds me of teeth. I don't know. But anyways, this is the same as that. Just to make sure we're really on the same page, each vertex here represents a multiply sign. and then this bar running through the middle horizontally is like fraction bars if you need them. All right. If you don't like have a fraction, you don't need to write anything there. I sometimes will see people like putting a 1 there just so that it feels like something's there. I mean, that's allowed. That doesn't change anything, but it's not required. Like I wouldn't have to do that either. All right. And a similar thing, let's say like I had a 1 over what comes after G, H. All right. So let's say I had an H there. If I were to keep this going, then in this bracket form, I could just leave the H there. I know for some instructors, some they will have a philosophy of like, yeah, you should put a 1 there too. So I guess it depends on your teacher. But like if you had a fraction there, I'd want the 1 there. You can't leave it blank. But in this bracket form, for me, at least for me, it seems obvious, dangerous word in education, but oops, I just used it. Obvious that a 1 would go there. So whatever makes you happy is the same math anyway. All right, now to my last example problem. All right, so let's say we were doing a little bit of a longer conversion, okay, 7.89 centimeters, and let's convert it to this really dinky unit of nanometers, okay? So I already solved this, and I took a double conversion approach. Okay, I have 2 conversion factors instead of just 1. In this video, I'm not going to argue whether I should have done it in 2 steps versus just like 1 step. Okay, I'm not going to argue whether, yeah, 2 steps versus like just 1 step. I will cover that at another time. And for students, I just say do the method that works best for you. Just for the sake of this video, I just went with like 2 different conversion factors to get to my answer of nanometers. What I did, okay, is I went from centimeters to meters. And then from meters, I went to nanometers. Okay. This kind of reminds me of travel, like air travel. Let's say we were trying to fly from, oh, we'll just say A, B, C. Let's say we want to go from A to C. Okay. There's a way of getting a direct flight. Okay. But often the case with air travel is you're going to have a layover airport. Okay. It's often like a regional hub or a national hub or something. And then you go to your destination. Okay. If you're unlucky, you might have multiple stops along the way. But let's just say for this analogy, you have 1 regional hub. Okay. That regional hub, bringing this back to math, that's going to be your base unit. Okay. And doing conversions this way, I believe, is a great way to do conversions because conversion tables exist that relate everything to the base unit, but conversion tables that relate one unit to another where they both have prefixes, that's not as common, okay? I will show that in a different video, but let's just stick with that. All right, so I'm going to show 2 different ways of going about using the calculator here, okay? If you have like any calculator, okay, and by any I just really mean any calculator, but I'm especially talking about the less expensive calculators, the ones that can only do like 1 operation at a time. I'm going to recommend a top divided by bottom approach, okay? If you have the type of calculator, more advanced, a little more costly, we're going to type like really 1 long string of text, like those graphing calculators, or something less expensive, like a scientific calculator here. I could type all these things in 1 text. Then you can type everything into 1 text, okay? And I'm going to show both ways, okay? All right, so with this top-bottom method, all right, I look at everything at the top, the numerator, and I just multiply them out. So I took that 7.89, I take that 1, and then I take that 10 to the 9th power, and then I got them lined up 1, 2, 3. I multiply them out, and then I get my answer. Okay, 7.89 times 1 times 10 to the 9th power. And there's that answer. Okay. Some calculators, I could just count. All right, fine, I'll do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the 9th power to get my decimal right there. If you have the ability to go to like scientific notation on your calculator, you could do it that way as well. All right. But there's my answer for the top. And then for the bottom, I'm like this, I'm sure some of us have the confidence to do in our head, but not everyone. Some people just want to type everything. So I'll just do that. Okay. 10 to the second power times 1. And we get 100, well, which is the same as 10 to the second power. All right. But point being, I got my top answer, which I put in a blue fluffy cloud. And then I got my bottom answer I put in a red box. Okay. So I take my top answer, divide by my bottom answer, and then I get my final answer of 7.89 times 10 to the 7th. Okay. So let me show me typing that. Here's my top, 7.89 times 10 to the 9. And then I'm going to divide by, oops, glare. I'll do that one more time. 7.89 times 10 to the 9. And then we're going to divide by 10 to the second power. Okay. And then we'll get the answer. Count. Okay. Yep. That was 7. So 7.89 times 10 to the 7th power. If you're not sure, okay, we had like 5 zeros there. And we can just type what we think is the answer. And then sure enough, we have the 5 zeros, okay, and the 789 there. So we got it. Okay. Now you might see that like, Josh, you put some parentheses there in some orange. What's up with that? All right. So I do have a comment about that. All right. And here is my comment. Okay. The long story short with the comment is parentheses for your denominator. Okay. Here's my key statement. It's always safe. It will never cause a problem to have parentheses for your denominator. Okay. To be a little bit more nuanced about this, you will need parentheses if your denominator has multiple parts to it. Okay. Because otherwise, you're going to have an order of operations error. Okay. But if you never want to think about orders of operations, if you always put a pair of parentheses for your denominator, no matter what, you cannot go wrong with that. Okay. Some people will ask, how about the numerator? I mean, you can put that there too, but it's not required. Okay. If you don't believe me, try it both ways in your calculator and see that you'll get the same thing. Okay. But yeah, just to read that off in case my handwriting is not winning any awards, you will need parentheses for your denominator, aka the bottom, if it has multiple parts. All right. Now, what if your calculator allows for more than one operation on the same line? Okay. Then you can just type out everything you had at the top, type a divide symbol, and then put everything you had in your denominator after the divide symbol. And you can see here, I did use the parentheses. That's going to be my habit going forward. All right. So I got the parentheses there. It doesn't really matter again because we're just multiplying by a 1, which doesn't change anything. But just to get into that habit, I will use the parentheses. Okay, let's see. Try to get this on the same screen without the glare. Okay, one line. And as I'm typing this, you may be thinking, Josh, what do you prefer? I go both ways. It really depends for me. Like if this is like pretty short, like to me, but if like something gets really long, then I like to see everything in front of me. So then maybe I might go for a top bottom. But even then, I feel like I do this more often. Okay. Let me close that. And then, yeah, we got the same answer. Okay. Parting thought on my parting thought is this. Okay. In my experience, more students prefer doing this top bottom method and then calculating by doing top divided by bottom gets you your answer. If you go that way, that's great. It's a nice, consistent method. I do encourage you to write out plenty of the calculator output. I would consider writing the entire calculator output. Okay. Especially if you haven't learned about sig figs, significant figures, significant digits, also known as rounding rules. Okay. If you haven't learned those yet, then just write out the entire calculator output, and that's going to be a safer way to go. Okay. But once you know how to do sig figs, significant digits, then you can then make a judgment call of whether you want to write out the whole calculator output or not. I think that's enough foreshadowing. I think this video is long enough. So thanks for watching and have a great day. Any questions, leave them in the comments. Take care.